Hi, this is Alex, and in this short tutorial video we're going to go over how to apply nodal loads to a simple span beam, like the one shown here. To start off, we will create a new model by going up to the New Model button. We can call this model Video 6. Everything in here looks okay, so we'll click OK. As you can see, we have a blank grid where we can create our simple span beam. And to do this, we'll just go to New Line, and we'll just make it a simple beam from the origin 10 feet away along the x-axis. Now that we have our simple line, we'll add some line supports to this. Our first end support will be a fully fixed support, and then our second end support, we will have to create a new one, and we're going to make this one restrained rotation about the x-axis, and we're going to allow it to move in the x direction. We'll click OK, and then we can graphically assign it to our beam. Now that we have our beam, we would like to apply nodal loads to our beam. To do this, we can go up to this button up here called New Nodal Load. Since we don't have a load case created yet, when we click on a new load, it's going to ask us to create a new load case, and this pop-up window will come up. For our load case, we'll just keep the action category as dead, and we'll name this one dead load. The self-weight is activated, and that's okay. We'll click OK. Now our new nodal load box pops up, and as you can see, you can pick which way you want your point force to go, either the X, Y, or Z direction for your point force. And on the right side, you can create a moment and pick which axis you want this moment to rotate about. For now, we'll have a -3 kip force in the Z direction, and we can also apply a rotational moment about the y-axis, and this will be, we can make this one 3 kip feet. In the bottom right hand corner of this window is a graphic area that shows you the loads that you are about to apply to whatever node you're going to graphically select. Once you hit OK in this window, you will see that your cursor has an icon next to it. This means that you can apply these loads to any node you would like. For now, we'll just click on one of our end nodes, and now you can see graphically the loading that's applied. We can right click anywhere in the graphic area, and this will cancel out our selection. Now you can see there are no nodes along the span of our beam. If you want to apply a load somewhere along the span of the beam, you're going to have to add a node. So to do this, we can go up here to the button called New Node, and now you can add a node using the coordinates, or you can also do it graphically. Right now we'll do it graphically, and you can see that when selecting, your cursor will snap to the exact midpoint of the beam, which is 5 feet. We'll left click, and then we'll right click anywhere in the window, and now you can see that we have a node in the middle of our span. With this node here, we can go up to our New Nodal Load button. We already have our load set. We can also change any of the loads if we would like, or add a load, or decrease or increase the load. We can click OK, and now we can click on the node that's in the span of our beam and apply the loads that we want to. We'll right click anywhere in the graphical area to cancel out the tool. And now I'd like to show you how to add nodes to multiple points on the beam instead of just the midpoint. We'll delete our loads, and we can also, by highlighting the node from left to right, select it without selecting the beam and hit delete. To add multiple nodes to the beam easily, we can go to the line, right click, and click on Divide Line, and we can do this graphically. You can see this pop-up window comes up where you can pick the spacing and the difference between the spacing and apply nodes that way. Or you can also, which is nice, go into the graphical area, and you can see that the points on the grid act as snap points for if you want to place nodes anywhere that correspond with the grid points. So click on the grid point 4, and then that splits up the beam right there at that point. And we can also keep splitting up the beam at these grid points. We click divide and we click exit, and now you can see that our beam has been split up at these grid points that it is connected to. We can then go to our New Nodal Load button and click OK, and then we can click on our nodes and add our nodal loads to them very easily. As you can see, our member was divided up into separate members. We can easily get rid of these loads by clicking Ctrl Z and get rid of our nodes. And now our line is back to just being one single line with no divisions. You can also right click on the line and divide the line by n intermediate nodes. So now you can pick how many nodes you would like to divide the line by. We'll keep it as 1, and we'll click OK. And now you can see that it equally divides the line up with one node in the middle. Now if we would like to divide the line by the first quarter of the line, we can right click on the line, select Divide Line, and go to Distance. The first thing we would like to choose is Type of Division. We're going to divide the line by new intermediate nodes. You can also place a node without dividing a line if you'd like. We're going to do this using the true member length of 10 feet. You can see how this works up in this graphic area. And then we want the node to be placed 25% of the member length away from the start of the line, which is 75% of the member length away from the end of the line. And you can see that automatically adjusts over here. So we'll click OK. And now we have a node that's 2.5 feet away from the beginning of the line. And we can apply our nodal loads by clicking New Nodal Load, clicking OK, and clicking on the node. Now we would like to run our results. Right now there's no cross-section or material set to our line, so we're going to select both of our line segments, double click on them, and then edit line box will come up. Up here in the member tab, we want to click member available. We can then go to our cross-section library and select which cross-section we would like to apply. We'll just apply a W30 by 90, click OK. And as you can see, our material is set to steel A992. We'll click OK. We'll click OK again, and now we have our rendered cross-section and material along with our loads. We'll run the results, and as you can see, turning this into wireframe view, we get our deformation along with our member diagrams for our moments and our shear. So thank you for watching. I hope this video is useful, and now how to apply nodal loads is more familiar to you. In the next video, I will be going over how to quickly apply a set of point loads organized as a member load. Thanks for watching.